All right, number 7. So we have a function here that's defined piecewise. And whenever you have a function that's defined piecewise, where the change in the formulas occur, that's a potential discontinuity. So here we're changing at x equals 0, so it might be discontinuous at 0. Both of these functions by themselves, though, are continuous everywhere. But when we piece them together using a piecewise function, it might no longer be continuous where we attach them, namely at x equals 0. So let's see what happens. Continuous. Let's use the definition that the left limit, by the way, I'm talking about continuous at 0, okay? Because like I said, it's continuous everywhere else. The only potential problem is at 0, so I just need to think about continuity at 0. One definition of continuity that I think is most useful on these kinds of questions is this. The left limit exists and equals the right limit, and both of those turn out to be equal to the functional value at 0. So let's see what these equations force A to be. Okay, let's first do the left limit, the right limit. When x is going to 0 from the right, that means x is bigger than 0. So I should use this formula for this particular limit. A minus 4 cos x. And this is a continuous function, so I'm allowed just to replace the x by 0. I drop my limit symbol and just replace x by 0. Cosine of 0 is 1, right? So this is a minus 4 times 1, which is just 4. So we've just calculated this first piece, all right? We know that this piece comes out to be a minus 4. Let's think about this next limit, the left limit. Well, if I look at the formula for f, when x is going to 0 from the left, that means x is smaller than 0. So it's to the left of 0. And I should use this formula, hyperbolic cosine. And hyperbolic cosine is a continuous function everywhere, so to do its limit, I can just put in the number. And we saw actually on the last question that hyperbolic cosine of 0 is just equal to 1. Very similar to cosine of 0 being equal to 1. So we've just calculated this value to be equal to 1. And in this case, f of 0, I think, I think it's the same as 1, right? If we look at it, when x is 0, I should use a minus 4 cos x. So actually it's this one, isn't it? So f of 0 is a minus 4 cos 0. Basically the same as the first line. All right, so we've just calculated each of these three quantities. They're right here. And as long as each of these three quantities are equal, this function is going to be continuous at 1 and hence continuous everywhere. So, well, obviously a minus 4 is the same as a minus 4. I guess the interesting thing is that a minus 4 is the same as 1. That's going to force a certain value to be equal to a, right? So we need, in order to ensure continuity, that a minus 4 equals 1, which is, of course, the same as a equals 5. And so if a is equal to 5, these graphs will match up nicely at 0, and it'll be continuous everywhere. So our answer is E. A equals 5. How about question 8 here? Well, this is just an ugly derivative here. It's not going to be very hard. This is a product rule. This will also be a product rule. I'll think of this as all being together, and this is the product right here. So let's do the derivative. The derivative of x squared is 2x, and then I leave e to the x alone. This time I leave x squared alone, and I multiply by the derivative of e to the x, which is e to the x. Now I put a plus sign, and now I'm going to work on this derivative. It's a product rule again. The derivative of this by the chain rule, 2 times 3 is 6. x plus 1 to a power 1 less, so it's power 2 now, times the derivative of the inside, which is just, the derivative of x plus 1 is just 1. So I don't even really have to write it, but I will anyway. And then I leave the second factor alone. Now remember, with product rule, then I have to leave the first factor alone and multiply by the derivative of the second factor. By the chain rule, the derivative of that is going to be e to the minus x times the derivative of minus x, which is minus 1. And that completes the derivative. Now, sometimes you would like to simplify this, right? But since we're asked a question here where we just want to put in a number, namely 0, let's not even bother simplifying. Let's just go and do it right away. When I put 0 into here, notice I just get 0 because of this x. 2 times 0 times e to the 0 is just 2 times 0 times 1, which is 0. This is similarly 0. But don't be too sloppy. Not all of them are going to be 0, right? When I put 0 in here, I get 6 times 0 plus 1 squared is just 1. Times another 1. I don't need to write that. E to the minus 0. We'll figure that out later. And over here, I get 0 plus 1 is 1 cubed. E to the minus 0 times minus 1. Let's see what we have here. These zeros don't mean anything. This is 6. E to the minus 0 is equal to 1, right? And so this entire thing is just 6. How about this part? Well, this is 1. So we have 2, and 1 cubed is 1. So basically we have 2 times 1 times 1 times negative 1. And that's negative 2, right? I'm getting 4 for my answer. And so that would be answer D. All right, number 9. How do we do this? This is basically the same question as we just did, except we're going to have to use quotient rule, right? So quotient rule, make sure you do the derivative of the numerator first. The derivative of sine is cosine times denominator left alone. Now I'm going to leave the numerator alone and multiply by the derivative of the denominator. So that's 2x minus 3 plus 0. And then notice the bottom, you don't do the derivative of that, right? You just leave it alone, but you do square it. So that's my derivative. It doesn't look like it can be simplified very much, but it doesn't even matter because we just want to put the value of x equals 0 in there anyways, right? So cosine of 0, which is 1. And then I put 0 in here. This is 0 minus 0 plus 4, so just 4. Sine of 0, which is 0. And then here I get 0 minus 3. When I put 0 in here, I get 0 minus 0 plus 4, so 4 squared. So this is like 1, right? 1 times 4 is 4. And sine of 0 is 0. So this is 0 times negative 3, which is 0. So 4 minus 0 over 16. So 4 over 16, which is 1 over 4. So our answer is D there.